Hello, everybody. Can you hear me? Well, the mic is for the live stream. You can hear me in the room, though, can't you? Okay, great. Hi, welcome, everyone. My name is Krista Hamill, and I'm the director of the Osher Lifelong Learning Institute. Thank you all for joining us in our presentation of Solar Eclipse of 2024, Land of Shadow and Light with Mark Breen. Before we begin, please take a moment to silence your cell phones or switch them to silent mode. This will help minimize distractions and ensure everyone can fully enjoy the presentation. We would like to thank our hosts from the Vermont Film Festival. We're excited about our new partnership and look forward to having more OLLI events take place in this intimate venue. Keep your eyes open for the summer launch of our new OLLI film series with film historians Rick Winston and Barry Snyder here in this space. Thank you, Ellen Vogt, for checking in everyone today and for your long-standing support for the OLLI program. I would also like to thank Hannah Day for her incredible support behind the scenes as our OLLI coordinator. Live streaming has been made possible today thanks to a great work and support of UVM's AV team, Foster and Eric. Thank you. Welcome to our live stream participants from near and far. There are about 45 of you online, which is wonderful. And now, a little bit about our speaker. Mark Breen is the Senior Meteorologist and Planetarium Director at the Fairbanks Museum and Planetarium in St. Johnsbury, Vermont. For 42 years, he has been heard on Vermont Public's morning weather forecast, Eye on the Sky, and on Vermont Public with the afternoon stargazing reports on Eye on the Night Sky. Along with weather forecasting, his work at the museum involves teaching weather and science, as well as creating and delivering presentations in Vermont's only public planetarium. Mark's award-winning children's book, The Kid's Book of Weather Forecasting, is now in its 5th printing. His comments are featured in the new book, Aratus Phenomena, a limited hand-pressed publication from Janus Press. Originally from Dannemora, New York, Mark has lived in Vermont since attending Linden State College, where he graduated in 1982 with a BS in meteorology. Mark makes his home in St. Johnsbury with his wife Sandy, where they enjoy gardening and golfing in the summer, hunting in the fall, and resting in the winter. And as we all know, he is formally taken over the role as rock star for Vermont in the spring of 2024. Please give a warm welcome to Mark Breen.
Well, thank you, Krista, and welcome everybody. I'm so glad to be here. This has been probably one of the wildest months that I've had, and got one more week to go. So it's fascinating. I mean, this is something that I've actually known about, probably in terms of paying attention to it, for about 30 years. There was an eclipse 30 years ago, May 10th, 1994, covered Vermont. It wasn't a total eclipse. It's what we call an annular eclipse. I'm not sure how much I have of that in my program, but I just wanted to mention that. So at that point, I had seen eclipse. I wanted to see another one. I looked it up and went, oh, 2024. I wasn't even sure I was going to still be around, but here I am. So, yes. So the idea of eclipses and so forth, actually, I'm a meteorologist by trade, so there is nothing inherent with meteorologists knowing anything about eclipses. And considering some of the things that I've seen other meteorologists say about eclipses, I can agree. I happened to, because I was working at the museum when I very first started, there was a planetarium there, and part of my job was to do a public presentation. I didn't have to know that much, I just had to be able to talk in the dark for 40 minutes. Okay. So the museum turns out to be just kind of a fascinating part of this story. So the museum was built in St. Johnsbury back in 1891. Franklin Fairbanks, he was the nephew of the inventor of the platform scale, and so he was just one of those people curious about everything. In fact, there's some story that he would literally come home with his pockets full of rocks and feathers and all sorts of things. Eventually, he collected lots of other things and built a museum in which to house that. And so that's, doesn't necessarily have anything to do with astronomy. It wasn't until later, back in 1961, that the director of the time, Fred Mould, was actually just absolutely keyed in on having a planetarium in Vermont. And this is, of course, the space race period of time. Sputnik had already gone up, and so it became Vermont's first and still only public planetarium. The original system lasted until 2011. We put a new system in 2012, the Lyman Spitzer Junior Planetarium, and so that's where the planetarium is at. Now, so what happened in terms of my own development was that I ended up learning a lot about astronomy, enough that I can teach college courses in it. I've just never taken one. So I know little bits and pieces about astronomy, about eclipses, and so that's what I'm going to share with you today. So here's actually just a quick little video of an eclipse taking place much faster. This process that you're going to see here takes about an hour and 15 minutes for the moon to cover up the sun completely. So this is not something you have to rush out and see immediately. However, the totality, when it's completely eclipsed, and you can see it was very brief there, it will last about 3 minutes here. So you have actually 3 minutes and, was it 12 seconds? Depending on where you are in Burlington, literally. It changes a little bit. But that is okay, so this is the rest of it taking place. So it really starts shortly before 2:15. It doesn't end until after 4:30. So there's actually a long period, in terms of, the eclipse itself. All right, so in terms of what we're going to feature this afternoon, we'll just explain eclipses. I think you've probably seen several explanations of that, but we'll go through that, especially in terms of thinking about the kinds of eclipses there are. There are several different kinds. Probably one of the biggest explanations, one of the questions I've been asked most frequently is, why are they so rare? In fact, the last eclipse in Burlington, do you know when it was? Anybody? Just curious. 1569. Yeah, 1569. And the next one isn't until 2381. They're not going to happen very often. So when I say this is a once-in-a-lifetime event, it truly is. We'll explain, best ways to view it. We'll also talk a little bit about how eclipses have been viewed through time. A very interesting sort of history of eclipses over really, truly millennia. And so we'll finish up, we'll explain a little bit about some of the science aspects of eclipses as well. So, when the moon covers the sun. So let's also, this is another sort of animation, if you will. You can see the three key components. You got the sun, the moon, and the earth. But that shadow is a pretty small spot on the earth. Now this particular eclipse takes place over 9,000 miles. From the middle of the Pacific until it gets out into the middle of the Atlantic. That's a long path, 9,163 miles or something like that. It's approximately 110 miles wide. It varies slightly along its eclipse path, but in terms of the amount of coverage on the globe, it's kind of surprising. Less than 5/1000ths of 1% of the globe actually sees this eclipse, the total part of the eclipse. I mention that because it's one of the reasons eclipses are rare. They cover a really tiny, tiny, tiny spot in terms of the globe. So thinking about eclipses, why they happen and so on and so forth. So you got the basic idea, the moon orbits the earth. As it does, we get different views of the moon. Those are the phases. And we're probably pretty familiar with those. The curved shape, the crescent moon. When it's half illuminated, we call it a quarter moon, which may seem kind of odd, except this picture, I think, illustrates it very nicely. It's 1/4 of the way around in its orbit. So that's how the quarter gets viewed. It is half illuminated, so half and quarter don't obviously quite match up. So anyway, we've got this process, the moon's going around, and which means, if you look over on the left-hand side, we have a new moon once a month, every 29.5 days to be more specific. Every 29.5 days, the moon goes between the Earth and the sun. So we should have an eclipse every month. And we don't. You'd probably notice that by now. Okay. So thinking about that, when it is perfectly lined up, you do get an eclipse. Eclipses happen somewhere on the globe about once every 18 months, a total solar eclipse. There are partial eclipses that happen a couple of times each year. But in terms of a specific spot getting an eclipse, you can see it's very small. On the other hand, I've got an image up there on the top. That is the moon's shadow on the Earth. It was an image taken by the International Space Station. So you can actually see the effects there. You can see the shadow of the moon on the Earth. Now, in terms of this being rare, not being lined up, this is in some ways the very specific answer. Unfortunately, the scale doesn't quite help you with this. The moon is not orbiting the Earth at the same level or plane that the Earth is orbiting the sun. So in other words, the moon is tilted. It's either a little bit above or a little bit below the Earth, and therefore it almost is never perfectly lined up. It's one of the reasons that eclipses are rare. So to think about that in a little bit more detail, so you can see they've got the shadows sort of illustrated here. You can see both on the left and the right, the shadows do not match up. And yet, in the middle, top and bottom, things are lined up. You can have, at that point, an eclipse. They mention here nodes. You don't have to know too much about that. It is essentially the intersection. It's where the orbit of the moon and the orbit of the Earth are lined up perfectly with the sun. And so you get this eclipse. So here's another way to sort of imagine it here. We've got that shadow of the moon aimed toward the Earth as the moon covers up the sun greater and greater. Eventually, if things are perfectly lined up in a particular spot, you can get a total solar eclipse. Now, if things aren't perfectly lined up, and that's certainly true in this particular eclipse, we have a total eclipse here. But if you go south of Middlebury, it's not total. If you go south of Montpelier, actually Barrie, I believe it's just south of the Norwich University campus. I mean, it's very fussy. There's a lake over where I am, Harvey's Lake. It literally goes right across the lake. The beaches on one side where people will go swimming, that's going to be an eclipse. Where the fishing access is, there's no total eclipse. So, and there's a real difference between a total eclipse and a partial eclipse. We'll talk a little bit more about that. So I mentioned this idea of the total eclipse, so the eclipse path that you can see here. Notice that as you go away from the center of the path, and it goes right through Texas, Arkansas, all the way up, it goes right through Indianapolis, Cleveland, Buffalo, right over us. As you go away from that, decreasing amounts of the sun are covered. And yet, every place in the United States sees at least part of the sun covered up with the moon. So you get at least a partial eclipse throughout the United States. So partial eclipses. One, they're more common because the tiny spot that is perfectly lined up, that's very, very tiny, but you've got the entire United States seeing at least what we call a partial eclipse. And so the last partial eclipse here, and it was actually quite an interesting event anyway, 2017, 7 years ago. There was a partial eclipse. It was kind of interesting at the museum because we knew there was a partial eclipse. We set out some telescopes. We had, probably about 6 or 7 of us on hand, expecting, we might see 100, 200 people. 800 people showed up. And this was just a partial eclipse, but what it did is, well, one, it was great. I mean, wonderful to have all those people there. Everybody was very interested in it. They got a great experience. But it also told us, because now it's only 7 years ago, I already had, this particular date in mind. I'm going, if that's how many people are going to show up without really a whole lot of advertising and so forth, and people just kind of, all of a sudden there's 800 people here, what is it going to be like next Monday? We still don't know, but we expect there'll be more than 800. Okay, another detail that comes into play in terms of whether an eclipse is complete, partial, so forth, is the fact that the moon's orbit is not a perfect circle. It is extended. We call it an ellipse, okay, an oval, if you will. And so we have the moon sometimes closer to the Earth, sometimes farther. The way that you probably notice this or hear about this most often, supermoons. I don't know if you, okay, so first of all, that's not an astronomy term. I try to avoid that term as much as possible in the planetarium, but it's what people hear. So when we get the moon as close as it does to the Earth, and this happens once a month, we call that perigee. And if it's at its most distant point, apogee. Now the thing about that is that this can occur not necessarily during a full moon or a new moon. It can happen at any particular point during the moon's orbit. So that is an additional aspect. So in fact, the moon can be far enough away at apogee. And so again, here's again, supermoons, they also call them micromoons as just another term. But it does make a difference. It's actually a noticeable difference in the sky. Well, I say that because I can show you very specifically, you can see the difference. But the moon isn't that big in the sky. In fact, here's a little surprising thing, and you can try this out anytime you see the moon in the sky. Well, actually, I'll just ask you, just for fun. If you hold your arm out straight and put the moon between your finger and your thumb, how big is it? I'm just curious. I mean, how big do you think it is? Not very big. You're right. It's not very big. It's 1/4 of an inch. I can stand here and look at that and going, it can't be that small. And every time I walk out and try it, yep, it's that small. So here's why I say that in terms of the supermoon versus micromoon, perigee, apogee, however you want to term it. One way to think about it is that the difference between a large supermoon and a micromoon, if you could see a 15-inch pizza at 100 feet away, the difference between that and a 16-inch pizza is the difference in the size of the moon. I don't think I could pick out 15 versus 16-inch moon or pizza 100 feet away, but that is, the reality of it. Okay, so if the moon is far enough away, if the moon's near its most distant point, its apogee, we get what's called an annular eclipse. Annular means ring. So not annual, that's obviously every year. Annular, the other probably more common thing that you would run into in terms of annular rings would be tree rings. When you cut a tree through the growth rings in the tree, those are annular rings, just to give you an idea. So anyway, this is the kind of eclipse that I saw back in 1994. It wasn't a total eclipse, and you can see, there's a very visible difference right there. When the moon doesn't completely cover up the sun, whether it's a partial eclipse or an annular eclipse, you do not see that faint ghostly glow around the moon. That is a unique thing to total solar eclipses. So here is a series of images from that annular eclipse back in May 10th of 1994. By the way, the weather was cloudy, but not solid overcast. It was enough that every once in a while, the sun would just kind of peek out through the clouds. You could just about make it out. I had a telescope set up so that it had a special filter on it. It was safe to look at through the telescope, but it was not a blue sky sort of day. Now, that could certainly happen with this upcoming eclipse. If it's not a blue sky kind of day, you will see the partial phases, you will see the sun disappear, but you won't see that corona around the outside. We'll just have to wait and see what the weather decides to do. Again, here is that annular eclipse. It's fascinating. It's a very interesting experience. There are occasionally, pretty rare, because the moon is, of course, if it's getting closer and farther from the Earth, at some point it's changing its distance. There are a few eclipses that go from an annular eclipse to a total eclipse. Depending on, if the moon's necessarily, if it's moving closer to us, then it's going to cover up more and more of the sun until you actually get a total eclipse. Those are called hybrid eclipses. Okay, so a little bit about eclipses and details. So from there, how often do they happen? So I mentioned some dates, but let's think about sort of a bigger picture here. And so I've got an image. This shows eclipses during a 20-year period all over the globe. And just to give you a quick little sort of tutorial on this. So the blue are total eclipses. So over 20 years, that's a pretty limited amount of space on the Earth that actually gets a total eclipse over 20 years. And then the red, those are, well, I guess it's an orangish red, but those are those annular eclipses where the moon is a little bit too far away, doesn't completely cover up the sun. And there is a hybrid eclipse in there, actually a couple of them. The one that's easiest to see is off the Central American coast, so between North America and South America to the left. It's just below, it says 2023 of, oh, that was last October. We saw a partial eclipse. Well, I shouldn't say that. We didn't see it, it was cloudy. But you could have seen a small bit of the sun covered up by the moon back in last October. Okay. So, eclipses, relatively rare. Most locations aren't going to see one over a period of 20 years. But let's extend that period. How many places get to see an eclipse over 5,000 years? These are the eclipses, okay, so total number of eclipses from 2000 BC to the year 3000, okay? And what you're seeing, so when I first saw this, I'm going, what am I looking at? So what you're looking at is any dark spot is a place that has seen fewer eclipses. Everything that's white sees 6 or more during 5,000 years, okay? And then actually in the bottom left, there's a 0 with a little red spot. Red. There's a couple of spots. One of them is in Africa. There's actually a little red spot in the middle of Africa, just right here. No eclipse for 5,000 years. There are also a few spots in northern Maine that only get one eclipse. Northern Maine's way up here. Northern Maine, only one eclipse. There's 3 spots. I don't know how they missed them, but anyway, that's just a way to sort of imagine that, yes, most everybody's going to see multiple eclipses over a 5,000-year period, but there are a few places, and it's not random. The moon isn't moving erratically. The moon is moving in a very calculated, very specific pattern. It's just that there are so many variations, it's more than 5,000 years for everybody to see an eclipse. Okay. So eclipses here, they are rare. There have been 2 since European settlement, 1806, southern Vermont, and 1932, the Northeast. And so I've actually got some maps to show you that. So this was June 16th, 1806. Because the center line went almost right through Boston, there's all kinds of early writings about this particular eclipse. There were a few entries actually from Bennington, A gazetteer that was published down there had a wonderful account of people going out watching this. They actually noted that there was dew on the grass during the eclipse. Animals went to bed, chickens and so forth went to roost. And so that particular eclipse, and you can see the northern extent of it, we'll just kind of get a closer look here, went through southern portions of Vermont. So not anywhere close to us. The last eclipse, moving across northeastern sections of Vermont, so 1932, it did go through St. Johnsbury, and we actually have a record from just about 20 miles north of St. Johnsbury. Somebody did weather observations every 5 minutes during the eclipse. The temperature dropped 10 degrees just because the sun disappeared. I mean, it's that effective in terms of reducing temperature and so forth. So yes, this was 1932, and it missed Burlington. You can see it went through Stowe, Cambridge, Swanton. Those are all on the edge of that, just east of Montpelier, but it didn't reach Burlington, and that's why, like I said, the last one in Burlington, 1569. All right, so more details about this year's eclipse. So the path, and you saw this before with that animation, but you now can see it. One of the things that it does is it actually goes through a number of relatively large cities. It goes through Dallas, Little Rock, Indianapolis, Cleveland, Buffalo. It actually gets into, well, of course, Burlington, but it does, it's a full eclipse in Montreal as well. Wow. By the time somebody calculated out, it's like 132 million people live within the path of that eclipse. That is more than lived in the path of the 2017 eclipse that went across the United States, and only the United States. This one actually goes through Mexico, the United States, and parts of eastern Canada. Now, these locations, many of them are much more favorable than here in terms of the weather. It's generally sunny in Dallas and Little Rock, and even as you get into Indianapolis, much more sunshine on the average than we get. But guess what? It looks like there's going to be a storm sitting there. So we may, keep your fingers crossed, we may actually luck out as far as that's concerned. So part of this amazing thing about this eclipse, I think it's amazing, is just how fast this moves. The shadow moves at about 2,300 miles an hour. The shadow of the moon, and this is a combination. You've got the moon moving and you've got the earth spinning. So you've got two things that are moving. It causes that shadow to move at about 2,300 miles an hour. And so it enters Texas right around 1:30 Central Time, which would be 2:35 our time. So it goes from Texas to Vermont in a little less than an hour. And a little less than an hour, about 55 minutes. That's a quick trip. Okay, so a little bit closer view of that here so that you can see, and you can see circled the shadow. That's the complete eclipse shadow. At 3:25, it sits over northern New York. By 3:30, it's exiting northeast Vermont. And by 3:35, it's already up in New Brunswick. So it really does move very quickly. So I thought we'd go into a little bit more detail specifically here. So first, this is the eclipse path. And so you can see this, the red line is the center line, the maximum eclipse, and the blue lines on either side, and it's slightly shaded in there. That is the area of the total eclipse. So we can see northern limit, southern limit, and the central eclipse. And so you can see, again, you get down to just north of Ticonderoga, a little south of Middlebury, and then it continues over into New Hampshire. The northern limit just gets into Montreal. In fact, on the north side of Montreal, it's not a total eclipse. So I've got a cousin up there. I think she's in the southern part of Montreal, so we haven't actually discussed that. All right, so the other thing is, I mentioned how fast this shadow moves. Here's the timing. Here's the timing. So, like I said, it's in the Adirondacks at 3:25, but look, in 1 minute, it goes from Malone right to just on the doorstep of Burlington. It's going up through Alburg at that point. So just 1 minute later. And 1 minute after that, it's already moved into Morrisville, Stowe, up into Mansonville, up in Quebec. So very, very quickly. And then 1 minute after that, it's moving right into northern New Hampshire and on into the far eastern townships. So very, very quick. Because the edges are not going to see the shadow there as long, we have a difference in how long the eclipse lasts. So if we take a look at that, there we go. So you can see, it goes from like nothing to a minute right on the edges, but you don't have to go very far. Just a matter of 10 miles makes a difference of a minute and then half a minute, a little bit more. But you can see in Burlington, we sit right between, it is 3 minutes. You get down closer to Shelburne, 3 minutes of totality. So about 3 minutes and 10, 12 seconds right here, and then 3 minutes and 30 seconds up here. And it's almost 3 minutes and 34 seconds or something like that in St. Albans. So that's the maximum amount of time. Also, something you can sort of see on this, notice that the 3 minutes and 30 seconds on either side of the red line gets narrower. That's because the moon is in the process of moving farther away. And so it's shortening the time of totality. So that's just kind of a curious thing that as I was mapping that out, it kind of showed up kind of interestingly. Okay. So I specifically worked on the timing here in Burlington. So this is specifically for Burlington. It just barely starts at 2:15. You can see just a little nick out of the sun at that point. By 3 o'clock, it is half covered up. 3:15, you're starting to get what we call a crescent sun, kind of neat looking thing. And we're going to talk about this a little bit more, but this is known as the diamond ring effect, which I'm certainly looking forward to seeing. And then, of course, totality starting here at 3:26. So, what are you going to be looking for during the eclipse? Well, obviously, you've got this whole basic pattern going on, but most of the time, we're talking about a partial eclipse. That moment of totality, which is really unique, but it is a rarely brief period of time considering the entire eclipse. So here's what you might want to try out during the partial phases, before and after the totality. Yes, I'm hoping that you all have your eclipse glasses, okay? But you don't have to have eclipse glasses to see some really cool things. For example, a spaghetti strainer. When the sun is a crescent sun, the light goes through those little holes and it creates all these little crescent suns down on the ground. It's kind of fun to look at, okay? And you can go really low tech. Use your fingers. Really, just cross them like this and you'll get those little tiny crescent suns. And a piece of paper or light colored cardboard or whatever on the ground, make a nice flat surface in order to project that. But then we have to think about totality. So just in the very seconds before totality and just after, we get something called Bailey's beads. These are these little tiny specks of light that appear. And the reason that they are specks, little tiny fragments of light, is because the light's going in between mountain passes on the moon. The moon's surface is rough enough that as you get on the edge, there are going to be some mountains there, and when the light goes through those little valleys, you get this bright spot of light. Now, you can't look at that directly. You do need to use your eclipse glasses to see it, and that's what you'll see. You'll see these little spots of light, okay? And it also tells you, don't take your eclipse glasses off yet. But when it is a total eclipse, yes, it is absolutely safe to take your eclipse glasses off. In fact, you kind of have to. At least if you're going to see this. To see the sun's corona, this is too faint to see through the eclipse glasses. This is 1,000,000 times fainter than the surface of the sun. So your eclipse glasses, they'll completely knock it out. But when you don't see any sunlight at all, you can take your eclipse glasses off. You've got 3 minutes and 15 seconds. Don't sit there with your watch timing it. Okay? Well, and I've seen several interesting sort of takes on what to do during totality. I've had a lot of questions about taking a picture with your camera. Okay, so first of all, taking a picture when it's not completely eclipsed is not recommended. All the phone manufacturers are basically saying you could easily damage the optics in your phone. So you don't want to do that. It's in some ways the same as damaging the optics in your own eye. And when it's total, yes, it is safe to take a picture. However, you've only got 3 minutes. Are you going to be wanting to fuss around for 3 minutes to get, oh, wait a minute? I've seen recommendations that basically experience it. They'll be professionals. They'll be out taking all sorts of amazing pictures. That's wonderful. That's what they do. There are eclipse chasers, people that go to as many eclipses as they can get to, and they will be taking amazing pictures. That's all great. But you only get 3 minutes out of your entire lifetime to experience this unless you go chasing eclipses. So it's been recommended. Experience this. You know, feel the change in the air. Notice what animals are doing. Notice what the people around you are doing. So this is, like I said, it's a really unique event. Now, there will be people with telescopes and so forth getting some amazing detail within that. It's one of the things that makes the corona not just special in terms of an experience, it also contains a huge amount of scientific data, which we'll talk a little bit about. Okay, so in terms of safely viewing it, so we mentioned the eclipse glasses. Okay, that really is, you know, an easy way to do it. Okay, and at the same time, you can make one of these. This is pretty easy. Okay, this eclipse box. I mean, literally, if you got, you know, a shoe box or something like that, and you cut 2 holes in it, one on the right-hand side, on the upper side, you would be looking through. The other, you cover back up again with a piece of foil. You poke a little hole in it. It says pinhole. You can use a sharp pencil or something like that. It doesn't have to be a perfect pin. You just want to let a very small amount of light in through. You can put a piece of paper on the inside of the box, white obviously, and you can see the eclipse that way. That's perfectly safe to look at without any eclipse glasses. And another thing you can try, but you have to be careful about this one. So you're sending the light through either a telescope, a spotting scope. You can do it. However, you're sending a lot of energy in through those lenses. It's recommended to do this for anywhere from 20 to 30, 40 seconds and then cover it up, because otherwise it could heat up the optics inside the telescope or spotting scope or binoculars. Okay. This one I haven't tried. I guess maybe this is the time to try it. So you take a mirror and you literally cut a small hole, dime size or smaller. You just take a paper punch and just put a hole in the paper, put the paper over the mirror, and then as the sunlight bounces off of that onto some, you know, wall or piece of board or whatever, something especially in the shade, you'll see again this reflected image, perfectly safe to look at without any fancy equipment. Okay. All right, so eclipses. Now, people have been seeing eclipses since people have been around, but what they've thought about them has certainly changed over the years. And I mean, we could take a very classic example, Stonehenge. So Stonehenge, 5,000 years ago. Stonehenge, this part of Stonehenge is actually the newest part of Stonehenge. This is not 5,000 years old, this part of Stonehenge. Stonehenge started out as a henge, which is actually what that means is a circle. It was a ditch. They dug a huge, huge ditch, and they filled in with chalk 56 evenly spaced holes. We still don't know exactly what they're for, but there's a pretty good guess about what they are for. 56 holes. Well, we do know that the moon moves back into the same place among the stars every 28 days. Okay, 28 and 28 is 56. Maybe they're using that to keep track of the moon and a little bit more exactly. There are various suspicions that maybe they were keeping track of eclipses. More likely, they were keeping track of lunar eclipses. So a lunar eclipse, it's essentially, instead of the moon blocking the sunlight, it is the Earth blocking the sunlight from the moon. So we have a lunar eclipse at that point. Haven't really talked a whole lot about those, but it's a more likely idea that that's what they were looking at. So, oops, wrong direction. Let's go this way. The dragon swallows the sun. This is a pretty common theme extending from China down through southern Asia over to India. This idea, and there's some fascinating things about dragons in China anyway. Part of the Chinese idea of dragons, of course, fire-breathing dragons, right? Well, one of the things that they thought about in terms of dragons, when they were looking for salt, they would find these salt deposits. But every once in a while, the salt deposit would literally explode. They'd have flames shooting out of it. They didn't know it at the time, but it turns out that salt deposits of those nature, they often are right next to natural gas deposits. So yeah, that's why the dragon, they didn't of course see the dragon, but they could see his flames coming out. The other idea though was that he swallowed the sun. And when he swallowed the sun, of course the sun, the life-giving force that's out there in the sky, they made all kinds of noise, as much noise as they could to scare the dragon, to get him to regurgitate the sun once again. That's not the only thing that ancient people thought, okay? Ancient Greeks actually did a lot of calculating, but I find this very curious. So where the moon's orbit crosses the Earth's orbit, and there's a specific spot, the Greeks kept track of that spot, but they called it the draconic spot, or draconic node, dragon. So the Greeks were thinking about dragons as well. I thought that was kind of fascinating. And yeah, so, okay, dragon swallowing the sun, very dangerous. Just saw this the other day. I was reading through more information. The Tlingit tribe, so that's in Alaska, they didn't have this horrible evil omen about the eclipse. They actually had the story that the sun and the moon were getting together in the biblical sense. And they were having children. And that's where all the stars came from. I thought that was just a very different view as far as that was concerned. Now, there is a story in Greek times. Thales, in about 500 BC, apparently there was this war that was going on between two warring tribes. It's a war that lasted 5 years. He said, if you guys don't stop fighting, I'm going to make the sun disappear. Apparently predicting there was going to be an eclipse. Now, we don't think that they could have predicted it quite that exactly, so we're not sure how true that particular story is. But we do know that the Greeks not only were working on predicting eclipses, watching very carefully the motions of the moon, the planets, and so forth, but once they did that, they started timing things out, like, for example, being able to measure the size of the Earth. So I don't know, if you still kind of latch onto that idea that Columbus is the first person that thought the Earth was round. It's pretty been disproven at this point, especially since the Greeks had written that when the Earth's shadow went in front of the moon, a lunar eclipse, the Earth's shadow was curved. The Greeks knew over 2,000 years ago the Earth was round. They just didn't know the size. Well, at least until Eratosthenes, he actually measured based on the difference in the shadow and the distance that he knew. He actually measured the Earth within a reasonable figure. He actually came really close to it, okay? But here's an eclipse that we don't think about. The planet Jupiter has eclipses. It has 4 large moons that go around it. Galileo discovered those. He was keeping track of them. These are actually Galileo's notes over on the right-hand side here. But one of the things that does is that if there is an eclipse going on Jupiter, and that's something you can see in a telescope, that happens at the same time, no matter where you are in the globe. Why is that important? It turns out that if the time is the same in terms of the event, then your local time. So before we had time zones, people kept track of time. Noon was when the sun was due south. So everybody had their own time. Well, if you knew what the time was, and we know the Earth spins once every 24 hours, the Earth turns 15 degrees every hour. So what they were able to do, knowing the exact motion that the Earth was making, measuring the time in these different locations, they could actually measure the distance of the Earth. So again, eclipses all of a sudden, and not just eclipses here, became a really important thing. In fact, it was so important that, yes, King Louis XIV, Sun King, France, had astronomers go all over the country measuring these differences so he could measure just how big his country was. He famously said, "I've been losing more territory to astronomers than to my enemies." France, as it turns out, was smaller than they had originally measured. Okay, but then we move into sort of the scientific era. And Francis Baily, so I mentioned Baily's beads, those little spots of light just before or just after totality. Francis Baily, he was actually the son of a banker, and his father actually made him go to work in a bank. Well, he did like his 5 years that he had to do, and then he left. He became eventually the head of the Royal Astronomical Society. But specifically, he was fascinated with these eclipses and made kind of the first study of these spots on the edge of the sun. He, in fact, became so fascinated, he went to the next eclipse. This took place in Venice, I think in 1842, and he started talking about, and you can see them here, it's a nice, he talked about the red protuberances around the edge of the moon during an eclipse. He didn't know what they were. There were these red spots. He was kind of curious about that. So we get into the photographic era, and that's really where the study of the sun kind of just leapfrogs ahead of time. This is one of the first pictures, actually, of the sun. This is an actual image of the sun, a picture of it. But you can see there are these things kind of sticking out around the edges. These, we now know, are solar flares. But you only could see them during total solar eclipses. And it's one of the reasons that literally people would get these expeditions together. They would travel across the globe to see this brief moment, again, solar eclipse, that moment of totality. That's the only time you can see some of these things. They now have some equipment that you can actually see this on a more regular basis. But at this time, this was the only way to be able to see it. So one of the things that they were doing is they noticed that glow of light around the moon during totality, they started using something called spectroscopy. And what that does is you can actually tell what the glowing stuff is, what it's made out of. They found out the sun's made of hydrogen and helium. Okay, well that was good. But then they found out all the stars are made out of hydrogen and helium. Hey, it turns out that our sun is a star. I mean, those are the kinds of discoveries that they're making because of eclipses. And then finally, probably one of the kind of modern science as far as that's concerned, but Albert Einstein, within his theory of relativity, they had a very different concept of gravity. That gravity, instead of this force that just sucks things in, it actually warps space. So if you could think of space as a fabric, as you get near something that's very large and dense, it actually curves the space, which means if you're trying to go straight and you hit that curve, you're going to bend. So that was what they did in 1919. They measured the location of the star, literally a photograph using an eclipse. So the apparent location, as you can see, there it is. That's where the star is. But no, that star isn't there. It actually appears to be there because the light was bending around the sun. Again, it proved his theory of relativity. It turns out that that improved certain things, especially. They thought that Mercury, the planet, there was something pulling on Mercury. Gravity was yanking on it. There was another planet. We just couldn't see it. They actually named it Vulcan. They looked for it. It never appeared, and it really wasn't until 1919, during that particular eclipse, that Einstein's theory became a better way to predict the motions of Mercury, and it was more correct. And so we get to the end of the program. So we have this eclipse coming up, and we have a huge program at the museum, and you'll see some of it if you watch Vermont Public, because we are doing a joint broadcast with the public television and radio. And so Jane Lindholm and I are going to be talking about the eclipse. During the eclipse, we are going to stop talking during totality. There is nothing to say. It's one of those, it's like I said, you really just simply need to experience it. And so I certainly encourage you to do that. So that is my program for this afternoon. So again, thanks for coming in today.
Thank you, Mark. We do have a couple minutes for a couple questions. Does anybody have any questions here in the room?
Oh,
it's a
right
quiet
behind
group.
you.
Did you say the next one will be?
So the next one that we can see specifically in Burlington is in 2381. So you mark that on your calendars, right? There is an eclipse that will be seen in southern Vermont. It goes from Albany, New York, I think Bennington, it gets up to, I think, Springfield, and then Laconia, New Hampshire. That's in 2079. So, yeah, I know. Well, for my kids, you know.
Any other questions? Let me come to you.
Thank you. Thank you. First of all, I'm just so excited to see you in person. I've
Well,
only
I'm glad
heard
to
you
be
on the
seen, so-
radio, and so this is a treat. But I want to know specifically, you mentioned that people can look at the total eclipse without their glasses. So do you recommend, so how would, if you've got your glasses on, will it just be black, or what do you experience so that you know you can take the glasses off?
Right, so you're going to be seeing either that diamond ring effect, so that diamond ring, so you'll see like the last spot of sunlight, and you'll see like a little curve of light on either side of it. That's the diamond ring effect. So when that disappears and you're looking, you can't see anything, then it's safe to take the eclipse glasses off.
Okay. Thank you.
Yeah,
Thank you
you're
so
welcome.
much.
And that happens at the end of the eclipse as well. So in other words, so now you got your eclipse glasses off. When do you put them back on? You're looking, and all of a sudden, oh, you see a hint, barest hint of sunlight. You see that? Put your eclipse glasses back on. Okay.
Thank you.
Yeah.
It's wonderful to hear your voice
Oh, thank you.
and to meet you in person. Would you be able to show that one slide of the timing in Burlington again?
The timing. Well, let's see here. So yes is the easy answer.
Okay, thanks.
Let's see if I can find it though. Let's go back. I have no.
Pass it to the next person if there's another question in this area. Anybody else?
Almost there. Why, I got a lot of pictures. Let's see. Oops. Let's go forward here. Whoops. Okay, good. Stay there. Yeah. There's the eclipse timing in Burlington. Okay. Yeah. Yeah, you're welcome.
Mark, what's
Yeah.
your long-range forecast for Monday?
This is my forecast. No, I have been looking at, once computer models got into the range of at least some reasonable idea of prediction. So one of the first things I was looking at was where bigger stormy areas versus fair weather was setting up. And then late last week, we started zeroing in on this storm that's coming up Wednesday through Friday. And I was actually really glad about that. Not because I want to shovel, 6 inches of really wet cement, but it meant that if this is a storm, it's relatively slow moving, and it's here Wednesday, Thursday, Friday, even Saturday, that's fine. But that means it'll be moving out by Monday. And that continues to be the projection on computer models as of this morning, but it's also 6 days away. And so, and it truly, you know, obviously we are at the mercy of it. One of the things that I learned a long time ago in terms of just weather prediction in general is that the long-term averages are a really important component of that. So in other words, you don't predict a 2-foot snowstorm when you don't usually get one in mid-May, for example. So on the average, 70% cloud cover here. So that's a 30% chance that we'll see it. I'm thinking right now we're on the better side of that 30%. So like I said, I'm optimistic based on what I saw this morning. Okay.
We have one more question.
Yes, sir.
Quick question, comment. Thank you so much. I don't know if this is, I heard that in totality that you'll be able to possibly see some other planets as well as comet, perhaps? Is that?
Yes. I'm not sure about seeing the comet because the comet is inherently faint. But indeed, you will be able to see above the sun, you'll see the planet Jupiter. Below it is the planet Venus. And if you look toward the south, you may see a few stars, and they just happen to be the brightest stars in the sky. So they include the stars of Orion and the great dog, the dog star as it's known, or Sirius. So you will be able to see a few of the brighter stars, yes, during totality. Yep. So you did remind me, and I'm just going to mention this. So I saw some information and some misinformation out there. Somewhere, somebody got the idea that the next total eclipse is in 2106. I've seen that in several places, so that's not correct. I did some double and triple checking on that. There is an eclipse that takes place in 2106. It's about 200 miles north of Montreal. So, but not here. Okay. So.
Any other questions? Thank you so much,
Great.
Mark.
Yes. Thank you. Thanks, everybody.